This video is about how to classify points of inflection. We can classify maxima and minima by performing a second derivative test. However, this test fails for a point of inflection as the second derivative at the point of inflection is always zero. How do you show a stationary point is a point of inflection without using the second derivative test? One way we can do this is by sketching the curve and analysing the gradient. If you want a refresher on differentiation or sketching curves, we encourage you to look at the Differentiation and Math Survival Skills web pages. We're going to start with the same example from the previous video on stationary points, using the function y equals x cubed. We have the gradient graph on the right here, dy by dx equals 3x squared. We have the stationary point at x equals 0, corresponding with the gradient graph being 0 at x equals 0. To the left of a stationary point, we have a positive gradient, and to the right of a stationary point, we also have a positive gradient. Now, the second derivative test fails here. The second derivative is 0 at x equals 0. Since the gradient is both positive to the left of a stationary point and positive to the right of a stationary point, we can classify this as a point of inflection, as points of inflection are characterized by the behavior of a gradient to the left and right of the stationary point. If a gradient is positive on both sides or negative on both sides of a point, then we have a point of inflection. In this example, we have the graph of y equals minus x cubed on the left, and its corresponding gradient graph, dy by dx equals minus 3x squared on the right. We have a stationary point here at x equals 0, and this matches with the gradient graph being equal to 0 at x equals 0. Now again, looking to the left of a stationary point, the curve is decreasing, so we have a negative gradient, and this matches with a gradient graph being negative for negative values of x. Similarly, to the right of a stationary point, the curve is still decreasing, so we have a negative gradient, and this corresponds with a gradient graph being negative for positive values of x. Again, the second derivative test fails here. The second derivative is minus 6x, which is 0 at x equals 0. But as the gradient is negative to the left of a stationary point and negative to the right of a stationary point, we can classify this as a point of inflection. The gradients are the same sign on both sides of a stationary point. Here's another example with a point of inflection. We have a graph of y equals x cubed minus 6x squared plus 12x minus 8 on the left, and its corresponding gradient graph, dy by dx equals 3x squared minus 12x plus 12 on the right. You can see the stationary point, this time it's at x equals 2, and this corresponds to the gradient graph being equal to 0 at x equals 2. Now the gradient to the left of a stationary point is positive, we have an increasing curve, and this matches with the gradient graph being positive for x less than 2. Similarly, the gradient to the right of a stationary point is positive, and this matches with the gradient graph being positive for x greater than 2. The second derivative is 0 at the stationary point. We can see that the gradient graph has its own stationary point at x equals 2, and also if we calculate the second derivative and evaluate it at x equals 2, we get 0. So the second derivative test is inconclusive, but as before we can still tell that this is a point of inflection, because we have a positive gradient to the left of a stationary point and a positive gradient to the right of a stationary point, so the gradients are the same sign on both sides, and we have a point of inflection. So to summarise, if a gradient is of the same sign to the left and right of a stationary point, then we have a point of inflection, i.e. if a gradient is positive to the left and right of a stationary point, or negative to the left and right of a stationary point, then it's a point of inflection. That's the end of this video. I hope it was helpful. If you want more worked examples or practice problems, you can always head to our section on maxima, minima and points of inflection in the Math Survival Skills webpage. Thanks for watching.